So this is a brief video lesson over section 8.3. 8.3 is over zero and negative exponents. So far every single exponent that we've dealt with has been positive and has been a whole number. So we have never encountered zero and or negative exponents. So this is what happens if you have a zero exponent. For example, if you have a problem like this, which is x to the third over x to the third. Well, this is a quotient of powers. You have the same exponential base being divided against itself, so you would subtract the exponents. And when you do this, you get x to the 0 power. Any base taken to the 0 power, with the exception of 0 itself, is going to equal to 1. So here's another example. If you take, let's say, 5 to the second power over 5 to the second power, same case as before, you have a pair of exponential powers that are being divided by themselves. So this is a quotient of powers. You subtract the exponents. So 5 to the 0 power is going to equal out to a 1. If you had something like this, where it was 3 to the third power times 3 to the negative third power, this is a product of powers. In this case, you add your exponents. So it would be 3, and the exponents would be 3 plus a negative 3, which is 3 to the 0, which is once again 1. So regardless the case, or the method that you get there, if the base is taken to the 0 power, the end result is a 1. Let's look at another problem. If you have something like this, where it is 2 to the 4th power times 1 over 2 to the 4th power, well, first of all, you would have to rewrite it with the 2 to the 4th power that's right here goes on top of the fraction, because you multiplied numerators against numerators, and this has a denominator of just 1. It's 2 to the 4th power of 1. So it's going to look like this. And then you would subtract your exponents, 4 minus 4, which gives you 2 to the 0 power, which is 1. The only exception to this rule is 0 itself. So 0 to 0 power is still 0. So 0 is the only exception. So any other base that is not 0 taken to the 0 power is 1. 0 is the only exception. 0 taken to the 0 power, 0 taken to any non-negative exponent is just 0. So that's zeros. So taken to the power of 0. Let's take a look what happens when you have a negative exponent. So for example, you have a problem like this. X to the second power over x to the 5th power. This is a quotient of powers. You have a pair of exponential forms that are being divided against themselves, same base, so you're going to subtract the exponents. 2 minus 5, which gives you x to the negative 3. Well, what do we do now? You can't leave an answer in exponential form. It doesn't work that way. You have to come up with an answer that only has positive exponents. So what you do to convert a negative exponent into a positive exponent, you take the reciprocal of whatever number you're looking at. In other words, you flip it. If the number is in the numerator, it goes into the denominator. If the number is in the denominator, it goes into the numerator. And in doing so, the exponent switches signs. It's in the numerator now, it goes into the denominator, and in the process the exponent goes from negative to positive. Fairly simple. Let's do another one. Let's say you have a 5 to the third power over 5 to the fourth power. Again, a quotient of powers, you subtract the exponents, 3 minus 4, which is 5 to the negative 1. Again, we can't leave it in a form where we have a negative exponent for the answer. So we take the reciprocal. It's in the numerator now. It goes into the denominator. And you can just write it as simply just 1 over 5. That's it. Let's say you had a problem like this. I apologize for the background noise. So you have, again, a quotient of powers. So you are going to be subtracting the two exponents. It's going to be 3 minus a negative 5. So you're going to get 3 minus a negative 5, which is going to give us y to the 8th power. So in this case, you didn't have to do anything specific as far as getting the reciprocal of the problem or flipping it, because your end result was positive. But let's see if you could have done it in a different way. So instead of doing it this way, you could have taken this particular denominator, and in order to make it positive, you could have flipped it or pulled it up into the numerator. So instead, so this is one way. You could have done it this way too. You could have flipped this up to the top, and let me write it like this. So you could have flipped this up to the top right here, and when you do that, you would get this, and nothing on the bottom. And now it's a product of powers where you add your exponents, which is y 3 plus 5, which of course equals out to y to the 8th power. So in a case like this, you do have a choice in the matter. You can either go with this route, or if you choose, you can go this route with the flipping. So it doesn't really matter. You get to the same answer. Your choice does seem to be a little bit shorter, so taking the quotient of powers in this case was a little simpler than going ahead and taking the reciprocal of the negative and turning the exponent positive first. If you had a problem like this though, 1 over x to the negative third. In this case, you wouldn't have a choice in the matter. There's nothing else to do but turn that negative exponent in the denominator into a positive exponent, and we do that by, again, taking its reciprocal, so make it flip. It goes from the numerator to, from the denominator to the numerator, which turns it into 1 times x to the third, which is just x to the third. Let's do one more problem. This one is slightly a bit more complicated. It's not too bad. We have 2xy to the negative 5th, all taken to the third power. So this is a power to the power problem, where you're going to multiply the external exponent by every single internal exponent. So over here, to the invisible one there, to the invisible one there. And that's going to give you 2 to the third, 1 times 3, x to the third, 1 times 3, y to the negative 15th. So far so good, except we can't leave that particular negative exponent the way it is. So we have to flip this down, which means we get 2 to the third power, x to the third power, and y to the now positive 15th power once it's in the denominator. So the only thing to finish this problem off would be to simplify. 2 to the third power, that's 8, x to the third, y to the 15th, and you write down that y cannot possibly equal to 0 because you can't have that 0 in the denominator, and you're done. So this was a brief overview of lesson 8.3. If you need any more help, please consult a book or see me at lunch, before school, or after school for some tutoring. Thank you very much.